Hello everybody. In this video, we are going to be talking about hydrocarbons and the types of hydrocarbons. So generally, hydrocarbons are divided into two categories. First, the open chain or the aliphatic hydrocarbons or compounds, and the second to be closed chain or cyclic compounds. The aliphatic compounds generally contain all the straight chain or the branched compounds, while the cyclic compounds contain the ring compounds. So what do we already know? We know that carbon forms covalent bonds with other atoms. Covalent bonds are those bonds where they share a pair of electrons with each other. Second, we also know what are saturated hydrocarbons. Saturated hydrocarbons are those compounds which have all single bonds between the carbons and the hydrogens. The next category that we know is the unsaturated hydrocarbons. This is denoted by the presence of double or triple bonds. Before we go into the classification of saturated and unsaturated compounds, let us discuss some of the root names required to name that particular compound that we will end up writing. So the root names are defined by the number of carbon atoms, and those names add as prefixes to our names. So if you have only one carbon atom, the name prefix is meth. For two carbon atoms, we call it eth. 3 is prop. 4 is bute. For 5 carbon atoms, it is called pent. And from here on, it will be easy for us because we have studied the same in polygons. So for 6 carbon atoms, we have hex. 7 is hept. 8 oct. 9 non. And 10 carbon atoms is dec. Now these root names will form the basis of writing the name for any of the carbon compounds that we are going to talk about. Now coming back to the saturated hydrocarbons. Now saturated hydrocarbons, as we all know, have single bonds between them, and the hydrocarbons which are saturated, they are called alkanes. Now going to the unsaturated hydrocarbons, the ones which contain double bonds are called alkenes, and the ones which contain a triple bond are called alkynes. Now let's first talk about alkanes and then move on to alkenes and alkynes. So here in this diagram, I have 1, 2 and 3 denoted here, which represent the number of carbon atoms. So for 1, we are talking about a compound with only 1 carbon atom. Now let's look at that. So if a compound has only 1 carbon atom, we know, since we are talking about hydrocarbons, all the 4 covalent bonds have to be filled by hydrogen. And this is exactly what happens. A carbon atom in the center and 4 single covalent bonds with hydrogen. Now let us look at what happens when you have 2 carbon atoms. So here are our 2 carbon atoms with 1 single bond, and we have, for the first carbon atom, 1 bond is already done, and this is the second, third and fourth, so 4 valency counts done. And for the second carbon atom, here again 1 is already done, and then you have this 2, 3 and 4. And this is the structure that you have when you have 2 carbon atoms. Similarly, for 3 carbon atoms, if you were to look at it, you have the first carbon atoms with first bond here, and then 2, 3 and 4 done. For the second carbon atom, however, 2 bonds are already taken care of while bonding with the remaining 2 carbon atoms. So 2 done, and then 2 hydrogens, and then that's why 4 done. And then for the third one, you have 1 bond here, and then you have the remaining 3 bonds. Now this is the structural formula of these alkanes. Now let's look at their molecular formulas. For the first one, with only one carbon atom, we have CH4, 1C and 4H. Similarly, for the second one, we have C2H6. And for the third one, we have C3H8. Now, if you look at these three compounds, we will see that the carbon atoms are increasing by 1 and the hydrogen atoms are increasing by 2. So, do we have a general formula onto how to write alkanes? Let's discuss about that. And yes, we do. Alkanes are generally denoted by CnH2n plus 2, where N denotes the number of carbon atoms. Now let's see that in action. If N equal to 1, then we will write C1, H 1 into 2, 2 plus 2, 4. So it is CH4. When N equal to 2, so you have C2, and for H, 2 2s are 4 plus 2, 6, C2H6. For N equal to 3, it is C3, 3 2s are 6 plus 2, 8. Similarly, C4H10, C5H12, and for N equal to 7, we have C7H, 2 7s are 14 plus 2, 16. And this is how generally alkanes are built, with increasing number of carbon atoms. Now let's look at the nomenclature of these alkanes. We had already discussed the root names that come with the number of carbon atoms. So going through that again, if you have one carbon atom, it is meth, 2 eth, 3 is prop, 4 is bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 dec. So these will be your prefixes, and the suffix for all alkanes is ane. Now what do I mean by this? Let's try writing the names of these compounds. So for the first one, if you have N equal to 1, the compound name, the compound formula is CH4. So to write the name, we look at the number of carbon atoms. We have one carbon atom, one corresponds to meth, so it is meth, and then it is an alkane, so we write ane as the ending suffix for it. So CH4 becomes methane. N equal to 2 for C2H6. We know 2 carbon atoms correspond to eth, and then it is an alkane, so we write ane, that is ethane. 3 is prop, propane. 4 is bute, butane. So like that you can go on to pentane, hexane, heptane, octane, nonane, and decane. And this is how you write names of these carbon compounds. Let's answer a few questions. What is the name of an alkane with 9 carbon atoms? Now, if you look at this question, we already know that we are looking at alkanes. So the name will end with ane. And we also know that we are looking at 9 carbon atoms. So the prefix for 9 is non. So the name of the alkane will be non plus ane, non-ane. Similarly, what is the formula for pentane? If you look at the name here, you have ane, so this is an alkane. And for pent, we already know that the number of carbon atom is 5. So the general formula for writing alkanes is CnH2n plus 2. Substituting for 5, we will get C5H, 5 2s are 10 plus 2, that is C5H12. Now, let us move on to unsaturated compounds. We already know that unsaturated compounds are divided into 2 categories. The first is double bonds, which are called alkenes, which will have at least one double bond, and the second is called alkynes, and they have at least one triple bond in them. Now let's look at writing the formulas of structures for alkenes. Now for alkenes, we know that we need a presence of at least one double bond, so that is how we will start with. And again, 1, 2, and 3 represent the number of carbon atoms. So for the first one, if you have one carbon atom and then double bond with hydrogen, this is not possible because we know hydrogen can only form single bonds. It has only one electron in its valence shell. So first alkene with only one carbon atom is definitely not possible. Now let's look at an alkene with two carbon atoms. So we can have C double bond C. So the alkene criteria of having a double bond is sorted, and then we go up filling the other valency counts. So for the first carbon, 1, 2 from these bonds, and then 2 more left, so that is 3 and 4 bonds with hydrogen. Similarly for the second one, we have 2 already taken care of out of 4, so now 2 remaining, those are the 2 bonds with hydrogen. And this is the alkene with 2 carbon atoms. Now let us look at what happens with 3 carbon atoms. So between C1 and C2 I have a double bond, and then between C2 and C3 we have a single bond. So let's try filling up all the hydrogens together. For the first carbon atom, 2 bonds here done, so remaining 2 are going to be bonded with hydrogen. For the second carbon atom, 2 bonds done on this side and 1 bond already done on this side. So 3 are taken care of. So now you are only left with 1 empty space, so that is going to be filled with hydrogen. Now next we have this carbon atom. This carbon atom is already bonded here, so 3 more spaces left. So those are going to be taken with hydrogen. So now to look at the molecular formulas. For the alkene with 2 carbon atoms, the formula is C2 and H4. So that is our first alkene. And then for the formula of the alkene with 3 carbon atoms, we have C3 and then H1, 2, 3, 4, 5, 6. So C3H6. Now to talk about the general formula. If you look here, then the number of hydrogens is exactly double that of the number of carbons. So 2 into 2 is 4, 3 into 2 is 6, and that is the general formula. For alkenes, the general formula thus becomes CnH2n. Now let's see that in action. N equal to 1, that's not possible. You cannot have an alkene, so that's done. N equal to 2, so you have C2, H, 2 into 2, 4. N equal to 3 is C3, and then H3 into 2, 6, so it becomes C3H6. Similarly, N equal to 5 will become C5, 5 2s are 10, H10, C7, H14, and so on. Now again to talk about the nomenclature part. We have already discussed what happens with the prefix, and the prefix factor remains the same throughout. So 1 starts with meth, 2 eth, 3 prop, and so on to 10 dec. And then we only have to change the suffix. For double bonds, the suffix is -ene. That is why they are called alkenes. So that E is the suffix. Now let's start writing it. Methane is not possible because we just saw that one carbon atom cannot form an alkene, so that's ruled out. So for N equal to 2, you have C2H4. 2 corresponds to eth, and then it's an alkene, so it is ethene. 3 corresponds to prop, propane. 5 corresponds to pent, pentene, hexene, heptene, octene, nonene, and decene. So this is how the nomenclature goes in terms of the alkenes. Now let's answer a quick question. What's the formula of an alkene with 10 carbon atoms? So we know that it's an alkene and it has 10 carbon atoms. So the name definitely should have been decene. So what's the formula? We already know that the formula is denoted by CnH2n. And since you have 10 carbon atoms, you substitute N equal to 10, C10H, 2 into 10, 20. So C10H20 is the formula for decene. Now let's extrapolate the same knowledge into alkynes. So, like in the case of alkenes, alkyne with one carbon atom is not possible. Again, hydrogen can only form single bonds and not double or triple bonds. So now going on to the alkyne with two carbon atoms. So you can have C triple bond C, and that is the first alkyne. So this carbon atom has 3 bonds done here, one left which is going to be paired with hydrogen. And similarly, the second carbon atom has 3 bonds here and then one left which is going to be paired with hydrogen again. Now let's look at the third one. With 3 carbon atoms, the alkyne formed is something like this. So for the first carbon atom, 3 bonds done with the neighboring carbon, so one left that's bonded with hydrogen. For the second carbon, however, 3 done with the first one and 1 is already taken care with the next one. So 4 valency counts are already filled, so there is going to be no hydrogen here. For the third carbon atom, 1 is filled with the second one, so you have 3 empty spaces, so that is taken up with hydrogen single covalent bonds. So now to look at the molecular formulas as we did for alkanes and alkenes. So for the alkyne with 2 carbon atoms, the molecular formula now becomes C2H2. And for the alkyne with 3 carbon atoms, the molecular formula is C3H4. Now to look at the general formula for writing any alkyne. The general formula of alkynes is CnH2n-2. Now to see it in action, let's write the formulas of alkynes with increasing order of carbon atoms. We know that for n equal to 1, an alkyne is not possible, so that is ruled out. So for n equal to 2, substituting the value of 2 for n, you have C2, H, 2 into 2, 4 minus 2 is 2, so C2H2. Similarly for n equal to 3, we are substituting the value of 3, so C3H, 3 2s are 6 minus 2, 4, so C3H4. n equal to 4, C4H6 and so on. So coming back to nomenclature, we have already seen the prefixes and the prefixes will remain constant. So we go from meth, eth, prop, but, pent, hex, hept, oct, non and dec. The only thing that changes when we are naming alkynes is the suffix, and which is "-ine". So we follow the same pattern. We know that for n equal to 1, an alkyne is not possible, so that's ruled out. For n equal to 2, we have C2H2. C2 corresponds to eth, so it is ethyne. C3H4, 3 carbon atoms, so that's prop, and that with the suffix "-ine becomes propyne. C4, but plus suffix "-ine, butyne. Similarly, you go on to pentyne, hexyne, heptyne, octyne, nonine and decyne. So let's solve this quick question. What is the formula of an alkyne with 7 carbon atoms? So for writing the formulas, we already know the general formula of an alkyne, which is CnH2n-2. For writing the formula for the one with 7 carbons, substitute n equal to 7. So C7H, 2 into 7, 14 minus 2 is 12. So the final answer is C7H12. And the name of this compound will be heptyne. So to summarize, what did we learn today? We started talking about the types of hydrocarbons, where we specifically spoke about the open chain or aliphatic compounds and closed chain or cyclic compounds. In depth, we went under open chain or aliphatic compounds and we studied the 2 classifications under them, which were saturated compounds and unsaturated compounds. So under saturated compounds, you had alkanes, which were hydrocarbons with only single covalent bonds. And then moving on to unsaturated hydrocarbons with double covalent bonds, we call them alkenes. And then the unsaturated hydrocarbons with triple covalent bonds, were called alkynes. We also learned how to name these parent chains with prefixes and suffixes. And that's it for today. Happy learning!